Okay, so we have time to get this one done. Here we go. Step one, factor. So what did you do? Hopefully difference of squares.
And then x plus, or 2 times x minus 2x plus 1.
Yeah, let's take a 2 out of the bottom. And if we take a 2 out of the bottom, we're going to have our 2. And then what'd you say? X minus 2, x plus 1. And anytime I factor, I do a quick little check in my head or on the paper to make sure that when I FOIL it, this is indeed what I get. All right, did you notice you have a cancellation? Please do not lose the 2. The 2 has to stay as part of the problem. It's going to impact your answers. Because we had a cancellation, we're going to have a hole where? At 2 something. And to find the something, we'll put 2 in here. So that will give us 4 over 2 times 3. So 4/6
2/3
or 2/3. So we're going to have a hole at 2 comma 2/3. All right, so far so good? Now, the whole list will be there for you, but we need the horizontal, vertical, x-intercept, and y-intercept, right? In addition to the hole that we already found.
Horizontal asymptote, y equals 1/2.
Horizontal asymptote is y equals 1/2. Make sure you write y equals 1/2. And why is it 1/2? Because we have x over 2x. Or in the beginning, we had x squared over 2x squared. Either place. See how it's 1/2? Okay. Y equals 1/2. All right, what else do we have?
Oh, you can find your x-intercept. Oh, no, you weren't vertical. You can just solve for the bottom, like make the bottom equal to 0.
So the vertical asymptote is going to be at x equals -1. Because in case you didn't hear Matthew, he said, make this 0. That's your vertical asymptote. Make that 0. So that would be x equals -1. The vertical asymptote is what makes the denominator 0. Perfect. Our intercepts are points. And they're points that have zeros in them, and the zeros are not at the letter of the intercept. So an x-intercept has a y that's 0, and a y-intercept has an x that's 0. So then we can go back to our equation, which is this, and we can plug 0 in for x. That's what this says to do. Plug 0 in for x. So we would have 2 over 2? 1. So my y-intercept is 0, 1. And then for my x-intercept, I'm going to let y equal 0. And when I bring this over, it's still 0, because 0 times anything is 0. And it looks like x equals -2. Everything okay, Evan?
Yeah.
Okay. So -2, 0. Now, everything important we've got. So now we connect all the dots. Knowing that it's a reciprocal function, And these can be funky shaped, but I'm not giving you a funky one, I'm giving you a normal, regular picture. The only additional comment I wanna make is, make sure when you draw it, that your asymptotes are your curve is following the asymptotes. Don't be doing any curving, curve them down or whatever, that's not right. They follow the asymptotes. Okay? All right, those of you that had a question about that, is that helpful?
Yes, ma'am.
Who has another kind of problem?
A
Matthew?
graphing line. No, not that graphing, but a number line.
Number one.
Okay, inequality?
Yes.
Well, we've got 4 different kinds of inequality problems. Which kind is it that you want?
One that is harder.
So, there are a couple of,
You got X third.
there are a couple of inequalities that are a little bit, unusual. One that I want you to be careful of is like this one that has the squared in it. Now, because it's already factored for you, the first part is easy. You know your dots are at -3 and 1. That is simple. But the rest of the problem takes a little time because of the squared, you need to check a number here and here and here. And when I say check a number, what I'm talking about is pick a number, plug it in, and see if you get an answer that's bigger than 0, which is positive, bigger than 0. So if I put in -4, I would get -4 plus 3 squared, 1. I'll put it down here. And then -4 minus 1 is -5.
It's not.
When I multiply those together, do I get a positive result? No. So I don't shade that. Now I go here. You can't shortcut it. You have to try every single one because of that. This is the only problem that you have to do it every single piece of the number line. So now I pick something in here. I like 0. 0 plus 3 squared is 9. 0 minus 1 is -1. When I multiply those, it is not positive, so I don't shade that either. 2. 2 plus 3 squared is 25. 2 minus 1 is 1. When I multiply them, it is positive, so I color it in, and my final answer is just the numbers bigger than 1. Okay?
So if it's positive, you shade it. If it's not, you don't.
If it makes it a true statement, you shade it. In this case, that means positive, but if that had been less than, it would be shading where it's negative. You shade where it does this. Rita?
Can we do one where the denominator's bubble can't be shaded?
So, an inequality with a denominator. No inequality denominator can ever be shaded. So we need to look at an inequality with a denominator. So that would be something like, something like this. All right? So how do we start this one?
Subtract the 2.
Subtract the 2. You always want to get a 0. Always, your goal is to have a 0. If you don't have one, you subtract to get a 0. Now, this is another fraction, and you are going to subtract these two things. So obviously, we need a common denominator. So we'll multiply this one by x minus 3. That's all you have to do. Now they have a common denominator, and you can write it with one denominator. Now the numerator, be really, really careful with.
Plus 2 minus
You got x plus 2
Minus 2x
minus 2x
plus 6.
plus 6. You're always going to be distributing a negative here because you're always going to subtract this number over. So you're going to have a minus. You need to remember to distribute that. So negative x plus 8 over x minus 3. Now I know there's two dots. There's a dot for the top and a dot for the bottom. The dot for the bottom is easy. The dot from the top messes us up over and over and over again. Please don't guess. Set it equal to 0 and figure out that it's at x equals 8. So we're going to have a dot at 3 and a dot at 8.
And do you have to do that with plug-in?
Now, because of the or equal to, I'm going to color in the 8, but I can't color in the denominator dot, which is 3. Now I need to pick a number.
2.
2 is over here. 2 is over here. So if I put it in, I have 6 over negative 1.
Nope.
Is 6 over negative 1 greater than 0? No. So that one is not shaded. This one is. This one isn't. Remember, your shading will always alternate unless you have this. So that's a shortcut. That's a time saver. You don't have to check here. You can if you want. Figure out your answer is everything between 3 and 8. Okay? All right. I'm trying to help you double check. Don't want to shortchange you. Yes, I will see you tomorrow. Have a good rest of the day. Remember, if you're doing open house, you park off campus. Please put your markers and rags back.